Hello guys, welcome back to Maison African Motives. Still working on mathematics for grade 11 level. In this case, we are going to be focusing on analytical geometry from the question paper of November 2016. That is question number 3. So in this case, we have got, yes, that's DBE November 2016 question 3. So we have got this part of the question where we are given that in the diagram, we've got the point A, the point B, and the point C are vertices of triangle ABC. And from there, M is the midpoint of AB. So we're given this part here where M is the midpoint of AB. So this is where we've got our point M. So this is the midpoint. All right. Then we move on to the other part. We have got N is a point on CA such that MN is parallel to BC. So you're given that there is a point N here. This is where we have got our point N such that these two, they are parallel. So we know that from the midpoint concept, it actually means that also this N here is a midpoint. All right. So that's from our midpoint theorem. If you are to draw a line from the midpoint to another line, being parallel to the other line, it definitely, automatically gives this point N to be the midpoint of this line AC also. Okay, so that's not about the question. The question is on 3.1, where we are given to determine the coordinates of M, the midpoint of AB. So we have got the M, which is the midpoint of AB in this case. All right, so we've got the point A and we've got the point B from this part here. We've got our point A and our point B. So you can just say this is our X1, this is our Y1, this is our X2, this is our Y2. So we know that in order for us to determine the midpoint, M, which is, okay, so this is question 3.1. So M is going to be given as X1 plus X2 over 2. That's Y1 plus Y2 over 2, which is the formula that you're given from your formula sheet for the midpoint. So that's our M. The midpoint is going to be the value of X at A plus the value of X at B. So this is 6 plus 2. Okay, so you're going to have 6 plus 2, everything over 2. The value of Y, which is -2, the value of Y there, which is 15. So that's -2 plus 15, -2 plus 15, everything over 2 like this. So this gives us the midpoint of a point, okay? So from your calculator, properly insert your values. This is going to give us a 4. And if we properly insert our values, -2 plus 15 over 2 is going to give us 13 over 2. So thus we got the midpoint here. This M is going to be 4, 13 over 2. Just in case we might need this point, just indicate. All right, so that's our question 3.1. 3.2, we are now given to determine the gradient of Mn. So it's actually a condition in this case where we have got, remember, we've got the point M. So you can actually find the point N, then we determine the gradient. But if we check later on, because this is the same question, later on they are now asking us to calculate with reasons the coordinate of N. So meaning to say, we can't calculate this point N while least we are to use it on the other part. So meaning to say, in this case, they didn't want us to work from this point N. They wanted us to use another concept in order for us to calculate the gradient of Mn. All right, what is the concept that we can use? If you get back to the information that you're given before, we are told that Mn and Bc, these two, they are parallel. All right, so if Mn and Bc are parallel, what does it mean in actual sense? It's all about the gradient. All right, so this is 3.2. So take note that Mn is parallel to BC. So it means the gradient of line Mn is the same as the gradient of line BC. Okay, why are we focusing with the other part? Because Mn, we are just given the point M. We just given one point. We do not have this N. And later on, they're asking us to calculate the point N. So it means we do not need to apply the point N at this point. So we are going to work with what we are given. That is from B to C. All right, from B to C, do we have exact points? Yes, we've got exact points here. We've got point B and we have got point C. So we can calculate the gradient from there. B, being 2, 15. So this we can calculate the gradient of BC, which is the same as the gradient of MN. Remember, the point B was 2, 15, and the point C is given as -4, 3 from our diagram. So you can just name, say this is our x1, y1. That's our x2, y2. So we can calculate the gradient of BC. So the gradient of BC from the change in of y over the change in x, that's y2, minus y1 in this case over x2 minus x1. So we can substitute our values, y2, which is 3, minus y1, which is 15. So 3 minus 15 over x2, which is -4. So that's -4 minus x1, which is 2. So this can give us the gradient of MN, which is same as the gradient of BC. That is a 2. So that's the gradient of MN. So the gradient of MN is equivalent to 2. All right, so that is how we could have calculated this gradient from the concept of parallel lines. So it is very, very best for you to understand your lines. Parallel lines, they've got same gradient. Perpendicular lines, the product of the gradient gives us a -1. Okay, so that was the first part that we had on the application of gradients. All right, 3.3, hence or otherwise, hence it a continuation from the gradient that we calculated, or otherwise, that means we can apply any other concept. Okay, so we are going to focus on the hence. We are going to continue from the gradient of Mn. Now we are asked to determine the equation of Mn in the form of y is equal to mx plus c. Why so? Because we have got the gradient. So we've got the gradient of Mn in this case. Remember, we calculated the gradient of Mn here, and this is our gradient of Mn, which is 2. And we need to calculate the equation given the point M, which is 4/18/2. So you can be able to calculate the equation of Mn in this case. All right, so let me just write this. I will remove this part. All right, so this is 3.3. So we need to calculate the equation. That is the equation of Mn. All right, so we have got the gradient of Mn, like I said before, which is 2, and we have got the point M. So this is actually enough for us to obtain the equation. So what are we going to do in this case? Remember, we are told to leave this equation in the format of y is equal to mx plus c. So meaning to say here, we can apply either way. That is, we have got this part. Remember, we've got our formula from y is equal to mx plus c, or from y minus y1, which is equal to m into x minus x1. This can give us the equation. So from the first formula that we've got y, which is equal to m, that is our gradient, and the gradient of the line is 2, so that is going to be 2x plus c. So you substitute any point that you're given, and the point that you're given is the 4/13 and at point M. So this is your x and this is your y. So y is 13/2. So that's 13/2. You substitute into this equation is equal to 2x. Our x in this case, that's a 4 plus c. So we can be able to calculate the value of c. So that's 18/2 is equal to 2 times 4, which is 8, plus c transpose 8 to the other side of the equation. This is going to be a negative. That's 13/2 minus 8. Okay, so that's 13/2 minus 8 is equal to c. So c is going to be something like that's -3/2. So you're going to obtain -3/2 if you plug in your values properly. So that's the value of c, which gives us the equation, because previously we said y is equal to 2x plus c. The only part that was limiting us here is the value of c, and we have this value of c. So therefore, y is equal to mx, that is 2x. So we have got a 2x plus c, and our c is a negative. So the plus and the minus gives us a minus. So this is going to be -3/2. So that's our equation in the form of y is equal to mx plus c. This is the gradient intercept format. That is the one that you've got here. All right, but we can actually have the same equation from this format that we are given. We can actually formulate the same equation, or have the same equation from this format. We're saying y minus y1 is equal to m into x minus x1. So this x1, y1 is the point that you're given. So you're going to refer this time as x1, y1. So that means in this case, we are going to have y minus y1, which is, this is our y1, which is 13/2. So that's 13/2 is equal to m which is the gradient. So our gradient of the line of mn is 2. So that is 2 into x minus x1, and our x1 is a 4. So using this formula, you can actually have the same answer. What you need now is to expand the brackets on the right hand side. So this is going to be 13 over 2 is equal to, that's 2 is going to multiply x. So 2 by x, this is going to be 2x. We do the same thing, 2 and negative 4, which is going to be negative 8 in this case. All right, so transpose the negative 13 over 2 to the other side of the equation so that it can be a positive in this case. All right, so this is going to be a positive. So that's y is equal to 2x minus 8, but the 13 over 2, this part, like I said, it is going to be positive on this part. So that's plus 13 over 2. So y is going to be equal to 2x minus 8 plus 13 over 2 is going to give us the same thing like the previous part. This is going to be negative 3 over 2. So that's the same equation. Y is equal to 2x minus 3 over 2. Y is equal to 2x minus 3 over 2. From different conditions or from different calculation, we must obtain the same answer for the equation of a straight line. So it doesn't matter which format are you using, you are going to have the same thing on that part. Okay, so that was our question 3.3 on calculating this equation in the form of y is equal to mx plus c. Then we move on to the other part, which is 3.4. Calculate with the reasons the coordinate or the coordinates of point n. So we need to calculate the coordinates of point n in this case. But remember what I said before about this point n. I said n simply represents the midpoint. N is the midpoint from the n that we had. Okay, remember here we are given the point n, m, which is the midpoint from the line BA. But here being parallel to this line, then it means also n is a midpoint. So you're saying from the midpoint theorem or the midpoint concept, that line parallel through the midpoint of one side parallel to the second line. So this is the midpoint concept that you're going to apply. So n is the midpoint. All right, so here I'm going to have 3.4. So n is the midpoint of line AC from A to C. So this is the midpoint of AC in this case. So if n is the midpoint of AC, that means we're going to apply the same formula for finding the midpoint, that is adding the values of x1 plus x2 over 2 into y1 plus y2 over 2. So this can, in this formula, we can be able to add the values of x at the points that we are given at point A and at point C. So this is from A to C. Our point A, x at A is 6. Here it's negative 4. So that's 6 plus negative 4 over 2. We move on to the y value. The y value here is negative 2. The y value here is 3. So this is negative 2 plus 3 over 2. So this gives us the point n, which is the midpoint. So our n is going to give us 1.5. So that's our point n in this case. All right, so that is how we can be able to attempt such typical questions from the midpoint theorem or from the midpoint concept. All right, so question 3.5, we are now given that if A, B, C, D in that order, so we are given an order to apply or to follow in this case. So from this order that we are given, A, B, C, D is a parallelogram, determine the coordinates of D. So if there is a parallelogram that is referred as A, B, C, D, what is going to be the point D? Okay, let's take from note from our diagram, A, B, C, up to D. So this is what we are going to have from our diagram here. This is point A. I just want you to understand from the diagram so that when I'm calculating, you see what's happening. So this is A to B to C to D. Maybe D is somewhere this side here. That's where we have our point D, somewhere here. That's where our point D is. So what we know is that the point D, this one, and the point B, the diagonal from B to D, and the diagonal from A to C, they bisect each other. So if these diagonals, they do bisect each other, it means that the midpoint of AC, from A to C, we have got a midpoint, and we calculated that midpoint before, which is N. This N, the midpoint of AC, is the same midpoint from this B up to the point D that we are going to. It's only that my diagram is not accurately drawn, but what it means is that from the point B to the point D that we are going to have somewhere here, which is referred to as XY. It is going to pass through the point N, and the point N becomes our common midpoint. All right, so in this case, what I'm simply saying, okay, what am I doing now? Okay, let me try to write this way. I'm going to put it here. So what I'm simply saying is that from the 3.5 that you're given, we had a shape like this. We ended up formulating here. I'm just gonna sketch A to B to C up to D like that. Okay, so we are going to have something of this nature. That's a parallelogram. So just this is just a sketch. I want you to see what I'm trying to say. So this is your point A, your point B, your point C, and your D. So what I'm saying is that this diagonal, that is from C to A, and this one from B to D, they do bisect each other at a common point in this case. So this part here is the midpoint of AC, and we calculated that midpoint of AC before from A to C. We calculated the midpoint, and that midpoint was N. So this is the advantage that we are taking off this N that we see here. This N is the midpoint of AC. So it means it is the common midpoint from B to D on the diagonal, because diagonals of a parallelogram, they do bisect each other. So that means that's an advantage. We can be able to calculate the point D because we are given the point N being the midpoint. So it's actually the common midpoint in this case. So being the common midpoint for the diagonals, therefore it means our N, which is 1, 2, was calculated from D, which is XY. We just name point D XY. We are given the point B before, that was 215. This is this point B. We have it from our diagram. Take note, this is our point B, which is 215. So using the midpoint concept to say, how did we calculate the midpoint before? To calculate the midpoint, we added the value of X, that was X1 plus X2. We add X1 plus X2 here, which is this one, over 2. That is how you calculate the midpoint. You add the value of X here to the value of X, you divide by 2. So this gives us the value of X at point N, which is our midpoint, and our point N is 1.5. So that's 1/2. So the value of X here is a 1. So this is going to be equal to 1. The same thing that we are going to happen between the Y values. The Y value at D plus the Y value here, which is 15 over 2, is the same as the Y value at the midpoint, and the Y value at the midpoint is 1/2. So you do this, you just redo the same way that you used to calculate the midpoint, but you are calculating this in terms of unknown values, that is X and Y. By doing this, we have formulated equations that is in terms of X and in terms of Y that we can solve. By solving for X, we are automatically finding the point D, because that's X and Y. Okay, so let's solve from the first part. This is same as over 1, so you can cross multiply here to obtain X. 1 times X plus 2. This is going to be X plus 2. That's 1 times X is X. 1 times 2 is 2. Then we cross multiply to the other side. 2 times 1, which is going to be 2. So in order to find X, we can transpose 2 to the other side of the equation. So it's going to subtract. So 2 minus 2, that's a 0. All right, on the other part here, we can cross multiply, or we can take advantage of the denominators being the same. So it means the numerators are also the same. So Y plus 15 is equal to 1. Y is equal to, we transpose 1 minus 15, that's minus 14. Or you can properly cross multiply. Y plus 15 over 2 is equal to 1 over 2. So we can cross multiply these two multiplies here. y multiply 2 multiplies the other side. So that's here. If we multiply 2 times y, that is 2y plus 2 times 15, which is a 30. So 2 multiplies everything on this part. Then on this part is 2 times 1, which is going to be 2. All right. So we can actually determine the value of y here. We can transpose 30 to the other part of the equation. That's 2. Y is equal to 2. If we transpose the 30 to the other side of the equation, it is going to be minus 30 in this case. So 2 minus 30, that is 2 minus 30, which is negative 28 in this case. So to find y, divide by 2, so y is going to be negative 14. So as you can see, we are obtaining the same value of y, which is negative 14 by or working our equation from cross multiplication, or just applying the shorter way of by inspecting to say if these two are the same, therefore it means these two also are the same. Okay, so this is what you're going to have. Remember, the point x and the point y is our point D. So it automatically we are having the point D. So therefore our point D is going to be x. Remember, a point x, which is 0, and y, which is negative 14. So this is going to be our point D in this case, if this is a parallelogram. So from a parallelogram, you know that the diagonals, they bisect each other. So where they bisect each other, it becomes a common midpoint for both the given diagonal. So that can be an advantage to answer any question by knowing that concept. Okay, so these are the typical questions that you might be given on analytical geometry. As you can see, there was a total of 15 marks from question 3 of this question paper, November 2016, from for mathematics grade 11. So let's continue to revise as much question papers as we can, as we are preparing ourselves for the exams which are ahead of time. But for now, that's it, guys, from Amazon African Motives. Till we meet again.